Namaste. Welcome to this channel Chemistry Made Easy by Dr. ARM. We were discussing this molecular orbital theory, and in which we are going to see today the ionic compounds and molecular orbitals. Before this lecture, we were discussing the heteronuclear diatomic molecules. In that case, we have seen that one of the atom is more electropositive and another atom is more electronegative. So this electronegativity difference imparts the polar nature to the bond. As a result of this, we know that the electron density is not present at the exact center of the bond, but it is shifted more onto the more electronegative atom. For example, if we consider say this HF molecule, for instance, then we find that in this case the fluorine is more electronegative, and this is more electropositive. So that is why the electron density is moving in this direction. That is, it is more stationary on fluorine, because fluorine is more electronegative and it attracts, the nuclear force of attraction of fluorine exerts stronger electrostatic attraction on the electron pair. That is why the electron density is brought on the fluorine. Means, in short, we say that instead of remaining the electron density shared here, instead of remaining the electron density exactly at the center, when the electron density is exactly at the center, one electron is left on hydrogen and one on fluorine. That is equal distribution of electron which is expected in homomolecular diatomic molecules. But when the molecule is heteronuclear, then the electron density is shifted towards this. So there is such a large difference in the electronegativity between hydrogen and fluorine that the electron density is fully transferred to F, fluorine. So that is why here H becomes plus and F becomes minus. So electron is actually transferred from this hydrogen to fluorine. So there is actual transfer of electron from hydrogen to fluorine. This is because of the stronger electronegative nature of one atom and weaker electronegative nature of another atom. We can explain this using the molecular orbital diagram and taking suitable example. So in this point, we are going to see that what makes the formation of ionic crystal favorable. So what are the conditions required for favoring the process of formation of ionic crystal, and why free energy change must be negative and the entropy change must be positive for the formation of these ionic compounds. We will take the simple example of this lithium fluoride. So we will see this in case of lithium fluoride. In this case, we find that lithium is the member of first state group, which is highly electropositive in nature, and fluorine is the member of the 17th group, which is highly electronegative, and fluorine is the most electronegative element also. And that is why we are taking this example. Now in this case, we will see the molecular orbital diagram of lithium fluoride. So we will see this MO diagram. In this mode again, you will find that we are showing the atomic orbitals of lithium. Atomic orbitals of lithium. On this side, atomic orbitals of fluorine on this side, and molecular orbitals of lithium fluoride, MOs, we see in between them. So we know that the lithium has the valence shell containing only one electron present in the 2s orbital. So this is the energy axis we are considering. So it has this 2s containing only one electron. This is 2s containing only one electron, and on this side we will have the 2s. So this is 2s of fluorine, 2s of fluorine, like this. So we are just shown that it is transferred to the MO system. Now we are having the 2p orbitals, so which are lying like this. So this is 2p. And after linear combination, it produces the molecular orbitals like this. So there is formation of the molecular orbitals of bonding nature and antibonding nature. So we are having this molecular orbital of bonding nature like this. There are these non-bonding molecular orbitals of pi nature, pi, and this is about the sigma 2g molecular orbital. Then we are having these so this is 2 sigma star u. Now, if we show the electrons, there are 2 electrons in this 2s. There are 9 electrons in all in fluorine, out of which 2 are in 1s, 2 electrons in this 2s, and remaining 5 electrons in this 2p. So if you observe this diagram, you will find that the pi molecular orbitals does not have or do not have any matching symmetry orbitals from lithium. Therefore, pi molecular orbitals, that is px and py, will remain non-bonding. Only sigma molecular orbital is bonding in nature. Now if we distribute the electrons, 1 from this lithium and 5 from this, so totally 6 electrons are there. So these are distributed in this way. So there are only one here, this bond pair, only one bond pair here with this molecular orbital diagram of lithium fluoride, and these are non-bonding electron pairs. So this shows that the electrons present in this 2 sigma G are mainly because of this pz orbital of 2p of fluorine, and it shows that means larger contribution is from fluorine and very smaller contribution from this 2s of lithium. 2s contributes largely in this 2 sigma star U. So in this way you can observe this molecular orbital diagram. And now if we show the energies, the electron volt value energy level of this shows that minus 5.4 electron volt, and this has 18.7 electron volt, and this is very large, that is minus 40.2 electron volts. So you will find that these are the values of the energy levels, which shows that the level, so this 2s is much higher level and these are at much lower level. So the electron energy difference between these energy levels also shows that this 2s cannot show any contribution here. Now we will see that during the formation of this crystal lattice or lithium fluoride, there are several steps that is involved in the process of formation of the crystal lattice. So ion pairs are first of all formed, and then these ion pairs are converted into the crystal lattice. So the formation of crystal lattice is arising because of the attractive forces between these ions, that is Li plus and F minus. But before that, there is need of formation of this Li plus and F minus. So after formation of this ion pair, there is the second process that is called formation of crystal lattice. So there are steps involved in this process, and which we will see here. That first of all, the lithium in solid state is converted into lithium in the gaseous state. Then lithium from gaseous state is converted into lithium ion from gaseous state into gaseous state, and with the loss of 1 electron. So the next step is the formation of fluorine. Fluorine is in the form of F2, that is homonuclear diatomic molecule in gaseous state. So this on dissociation gives F atom also in the gaseous state. Now this F atom in gaseous state gains 1 electron and forms F minus in the gaseous state. And after this, the final reaction shows that these two species, these two steps show that there is formation of this Li plus and F minus. So next step is Li plus in the gaseous state plus F minus in the gaseous state forms lithium Li plus and F minus, that is ion pair in the solid state, that is crystals or lattice. So these are the steps, out of which we know that this state, that is called sublimation, because solid is converted into a gaseous state, that is called sublimation, and it shows energy change 161 kilojoules per mole. 161 kilojoules per mole. Then there is next step, that is formation of lithium ion, that is ionization, or that is called ionization. So this step involves ionization energy. So this is 531 kilojoules per mole. 531 kilojoules per mole. Then next step is the dissociation step, dissociation of gaseous fluorine molecule, and it involves or it requires the energy 79 kilojoules per mole, 79 kilojoules per mole. And the next step is formation of the anion. So it requires the electron affinity value, that is electron affinity energy. So here it requires, that is the energy required is minus 328 kilojoules per mole of energy. So overall reaction shows that this overall reaction shows that the formation of LiF, that is formation of ion pair, that is Li plus and F minus, shows the energy change, that is energy lost is 719 kilojoules per mole. So this energy lost is 709 kilojoules per mole. Then the energy associated with this energy lost during the formation of the crystal lattice, that is formation of crystal lattice also requires more value, that is minus 1239 kilojoules per mole, So the amount of energy lost during the formation of this ion pair and the formation of this crystal lattice is very large, and this proves that it proves that the formation of crystal lattice is very easy process. So the process of formation of two things, that is, this is the first step, this is the second step. So formation of the ion pair is also favored, as well as the formation of crystal lattice is also favored. So this process will become spontaneous when the delta G, that is free energy, is the free energy value of the delta G is negative. So if the delta G of this process is negative, then only the process is spontaneously taken place. Similarly, the entropy change of this process is positive, and therefore the process is also favorable. So the most important requirement is that delta H is very large and delta G is positive. So which shows the formation of ion pair with the release of such a large amount of energy. So lattice enthalpy for crystallization is large enough to overcome all the endothermic processes. So these values, that is enthalpy change values, are so large that they can easily overcome the endothermic processes, means whatever the energy is required for the carrying out this formation of ion pair and lattice. So these are easily overcome by the energy released in the form of as a result of formation of ion pair and formation of crystal lattice. So with this we have completed this point, that is ionic compounds. So it will explain you what are the factors which are responsible for formation or favoring the spontaneous process of the formation of lithium fluoride crystal lattice. Similarly, it will also explain what are the various steps involved in the process, that is sublimation, dissociation, electron affinity value, formation of the, that is ionization of the lithium and fluorine. So all these steps will explain the various changes taking place in this process. So we will stop our discussion here. Please subscribe to this channel and press bell icon and like button. So thank you very much.